For our system design project, we are looking at a microphone preamplifier with a simple equalizer. We have a list of lab equipment, and now we're going to get into the presentation. So here we have a electric microphone preamplifier. That's going to be the circuit to the left here. We have a low pass filter and we have a high pass filter. We then have a summing amp. After this, we have a capacitor here. It's not shown in this schematic, but we do have to add one here. It's going to be a 10 microfarad, just like this one here, to have it go into our low pass filter and our high pass filter. And that would actually be outputting at this point here. We're not using an actual microphone right here. We couldn't get our microphone to work, so we are going to be using a sine wave instead from our analog Discovery 2. That's it for the notes there. We have our schematics for each individual part here, and then we have our notes for each resistor and capacitance value that we're going to be using that's not listed inside of here. For the frequency and settings that we run these at, we should have included them here, however we didn't. These are going to be in the first lab. We discovered that through there. We're reusing this, and that can be found in the playlist link below the like button. Next, we have our summing amplifier, which was the LM386 and our OP27. The OP27 is used for our low pass and high pass filters. The LM386 we could not get to work for the summing amplifier. I will be tinkering with that more later, so there will be an update video if that works, or if I have time to even do that. However, we are going to be using an OP37 for this. It has a similar pinout, so it's not listed here. Next, we have hand calculations, which is calculating gain. We should have had calculations calculating the frequency, however we did not include them here. That should have been included though. Then we have our PSpice simulations. This is how we would go about building this project. Here we have the capacitor that we were talking about, the 10 microfarad. That's over here as well. We have our low pass, our high pass, and our summing amplifier, PSpice simulations as well, and a description of it also. After this, we have our sweeps displayed here. We should have drawn out the graph a little bit more on the x-axis horizontally, that way we could see the roll-off. We see the roll-off here, and then we have more graphs right there. Next is where we have our breadboard. Down here, we have the preamplifier. Our input is right here, and our monitor is right here for the channel 1. This is our output. We can see we have one channel going to the low pass, this is the high pass, and then we have one channel going into the potentiometer, which goes to our low pass. That's acting as the first resistor here. The potentiometer allows us to variate the resistor. And then for the high pass, we variate the resistor on the negative feedback. So that's why it goes from the output to this back to the input. Then we take both of the outputs and we put it into the summing amplifier. We have this line right here, and this is to monitor our output. Once we put the speaker in, it started clipping, so I will also be trying to figure that out if I have time to, but it seems like there's too much gain right here, and we need to have some way to minimize this. Now, if we want to test each stage individually, we could take our output wire and just put it right here with this capacitor. That tests the output of the microphone preamplifier. And that's going to look something like this. If we wanted to test the whole thing together, it would look something like this. When we're testing the whole thing, we use an amplitude of 10 millivolts. We can adjust our frequency, and we would also need to adjust our time base to see the difference. Now, for the preamplifier, we're also testing it at an amplitude of 10 millivolts, and we can test it at a frequency of 5 kilohertz. If we want to test the low pass and high pass filter, what we're going to want to do is put our input, this yellow wire, and the orange wire, the channel 1 monitor, right at the end of this capacitor. So it monitors the input, and then this blue wire, we can put it at the output of our low pass to monitor the low pass, and output of the high pass to monitor the high pass. So this is going to be our low pass filter. We use a amplitude of 500 millivolts. We use this for the high pass as well. The frequency here is about 10 hertz, very small, compared to our high pass filter, which uses a frequency of about 50 kilohertz or 20 kilohertz. Our amplitude is still 500 millivolts, and then we have a description of it right here. Now, if we want to test the summing amplifier, what we're going to want to do is take the negative channel with this positive waveform channel, and we're going, or the wavegen channel, and we are going to put it into the both inputs, because we have 2 inputs for our summing amplifier. And then we keep this output right here, and then we can monitor it. That's how we would test all the individual parts. And to test the speaker, we would just plug it in to see, but it would not work. And so that is the end. After this, we just have some sources, we have some notes, and we have the course. So thank you to the professor and anyone who helped with this lab project. It was awesome, very fun, and there was a lot of debugging working on the physical circuit. There's a lot of issues, however, we solved them with the preamplifier not working because of the initial wiring that was at the differentiator, because there's a differentiator, a low pass, and another low pass, I believe. And then there was issues with that summing amplifier. But it is finished, and we are done with the report and the class. Here is the breadboard. This is what it looks like right now. This battery is not part of it. We have the analog Discovery 2 over here. It's not connected to anything. We have an extra bag of microphones right here. I'm going to try to test it out later. But for this one, we've gone over the preamplifier before. I've moved some things around because last time in the previous video it actually did not work correctly. There's something wrong with how I wire the intro part up here. Now that it's wired correctly, we have our WaveGen 1 input. We have our channel 1 monitor. And this is going to go through here. It's going to go to right about here with the capacitor. This is going to be our output. The output is going to go to these two jumper wires. This one goes to the high pass. This goes to the potentiometer. That goes to the low pass. And we can see how the potentiometer works right here. We can use a little screwdriver that was included with the kit to go in here and actually adjust this right here to adjust the resistance. This is our low pass. This one is our high pass. And from here, it's going to go right into our summing amplifier. And then we have our output here. That's being monitored here. Again, we couldn't get the speaker to work, but that's because it seemed to be clipping. Hopefully there's an easy fix for that, I believe, but still have a lot to do with internships and jobs and other assignments coming up. So that's going to be all for this video. Thanks again for everyone who helped, and thank you for the professor for the amazing course.